Good morning, grade 9, or good afternoon, grade 9, whatever time you're watching this video. Um, Hopefully by now you've done the work. You've taken a picture of your work and you've emailed a picture to your teacher's uh, cloud.edu.pe.ca account. So what I'm going to do now is I'm going to provide you feedback for your questions. So if you have your sheet in front of you as we go through these answers, and just make a note of anything you forgot about or didn't do or things that you made mistakes on. Just make a note of them because tomorrow when we post the second reach back of this week, the questions are going to be similar, different of course, but similar. And any mistakes you made on the first reach back, hopefully you'll be able to self-correct on the second. So with that said, question number 1, I know that Mr. McNeil's students and my students have not done chapter 1 yet, but Ms. Gerard and Mr. Pendleton's have. So we're going to go through it real quick. If you want to skip this question, if you're one of my students, you can. But if you want to listen to it, it's also very valuable just to listen because it is a chapter you did miss and it's really easy, so it's not going to be something that's overly difficult. So the first question says, what is the angle of rotation and the order of rotation for this shape? So remember that in one full rotation, if I was to take this and rotate it all the way around, I would rotate it 360 degrees, okay? 360 degrees in one rotation. And what we want to do is we want to say, how far do I rotate it? How many times when I rotate this? The first thing is we're going to call the order of rotation. So if I rotate it that many degrees, I end up with a picture that's identical to what I started with. If I continue rotating it, there it is a second time, a third time when I keep rotating it, a fourth time, and a fifth time. Okay, so as I rotate that shape 360 degrees, the order of rotation is 5, okay? And that just means how many times did it appear as itself as you rotated the image 360 degrees. Now the angle of rotation, all we have to do is figure out how many degrees is it from here to there. How many degrees is this here, this x? And in order to do that, we can take our 360 degrees divided by the order of rotation. So if I take 360 and divide it by 5, I take my calculator here and go 360 divided by 5, the answer is 72. So therefore, the angle of rotation is 72 degrees and the order of rotation is 5. What does that mean? That means as I rotate this shape, I'll just hang on. As I rotate this shape, I rotate it 72 degrees and I have the original shape again. 72 more degrees, I have the original shape again, and so forth until I get to the very thing, last one, which is the original image. So it appears as itself 5 times, which is what the order of rotation means, and it is 72 degrees. I rotate it until I see what it is. So for Mr. Pendleton and Ms. Gerard students, that's the answer, 5 and 72. For my students, that's what you should have done. Chapter 2 is on rational numbers, and it says, without using a calculator, show all your work to prove you did this without technology. So the first thing is, what does square root, and we're going to take 25 mean? What does the square root of 25 mean? And we know that it means what number multiplied by itself equals 25. And since 25 is a perfect square, we know that the answer to this is 5, because 5 times 5 equals 25, so therefore the square root of 25 is 5. Now it gets a little bit more complicated when you have a fraction, but not significantly more complicated, because I have to ask myself the same question. What fraction multiplied by itself was 9/25? That's what the square root of 9/25 mean. So if I think about what was that numerator, is that numerator of 9 a perfect square? And it is, because 3 times 3 would have garnered the answer of 9. And for the denominator of 25, 5 times 5 gave us 25. So therefore, the square root of 9/25, when I look at it like this is the work you need to show, is 3/5. Okay? And to that, we're going to add negative 2/10. So I'm going to put negative 2/10 here. I'm just going to change it to a fraction. Okay? And we can do it one of 2 ways. I'll show you both ways. So we can do it this way, and I'll put a little arrow. So the square root of 9/25 is 3/5, and negative 2/10 as a fraction is written as negative 2/10. Or we can take 3/5 and say, what is that as a decimal? And since 3/5 and 6/10 are equivalent fractions, then 3/5 as a decimal is 0.6, and of course you could have taken a calculator and went 3 divided by 5, but it still would have told you 6/10, right? Plus negative 0.2. So no matter which way you did it, you could do it from a decimal standpoint, and that's fine, or you can do it from a fraction standpoint. Obviously, the decimal standpoint is easier, because if you think about adding these two decimals, I have 60 cents and I owe 20 cents. So if I pay off my debt, a positive 6/10 plus a negative 2/10 is a positive 0.4, and that's your answer. That's an easy one to do. But if I use the calculator, or sorry, the fraction, excuse me, I have to use common denominators. 3/5 is equivalent to 6/10. And 6/10 plus negative 2, in this case, I want to keep my denominator and add my numerators. And I end up with 4/10 as an answer. So if you use fractions, you ended up with 4/10 as your answer, or 4/10, or in lowest terms, 2/5. Or if you use a decimal, you ended up with 4/10 as well. By the way, if you're copying this down because you didn't show your work properly or you didn't show enough work, make sure you press pause, and it'll give you more time to copy it down, because I kind of go through these a little bit quick. Question 3, powers and exponents, says using exponent laws, and it's underlined for you. Simplify this expression to a single power. So if we follow brackets, exponents, division, multiplication, addition, subtraction, or BEDMAS, inside those brackets there's work to be done. So we're going to simplify the brackets first using our exponent laws. And if I look at this one here, 6 to the power of 4, or 6 exponent 4 times 6 exponent 10, our rule is keep the base of 6, and when multiplying, add your powers together. So what you would end up with when you multiply those two is 6 to the power of 14 divided by 6 to the exponent of 11. Once you have that, dividing like powers is keep your base and subtract your exponents, which will leave you with, for the entire brackets, 6 to the exponent of 3. Okay? So when I simplify this whole bracket using my exponent laws, I'll end up with 6 exponent 3. And then this exponent of 2 is outside the bracket. And our final step is, what is 6 cubed squared? And I'm going to just put this, I'm going to erase the rest of the stuff here. No, I'm not. I'm just going to put it up here. I'll just put 6 cubed squared. So what is our exponent law when we have a power to an exponent? Remember what this is. This is 6 cubed squared, which means 6 cubed multiplied by 6 cubed, which we know will be 6 to the power of 6. Another way we could have done that is say, when we have a power, our rule is, or our law is, keep the base and multiply your exponents. But either way, you end up with a final answer of 6 to the exponent of 6. Question 4 from chapter 5 is adding and subtracting polynomials. What is an expression in simplest form for the perimeter of this rectangle? Now, there are two ways you can do it. Perimeter is simply the sum of all of the sides of a two-dimensional object. So I could go 3x plus negative 2x plus 8 plus 3x plus negative 2x plus 8. And if I do this, I'm just going to simply add the monomials and binomials together. So 3x and 3x, gathering like terms, is 6x. 6x plus negative 2x, because they're like terms, is 4x. Plus negative 2x is simply 2x. So when I gather those like terms together, I end up with a positive 2x. And the positive 8 and the positive 8 makes positive 16. So our perimeter is positive 2x plus 16 as a perimeter. Now, alternatively, the perimeter of a rectangle can be written as 2 lengths plus 2 widths, right? Because there are 2 lengths here. Add that to 2 widths, and you would have the distance around it. So you would have 2 negative 2x plus 8, and you would have 2 3x's. And if you put those together, you would still end up with this here. So your final answer, the perimeter of the rectangle, is 2x plus 16. Chapter 5 on graphing linear relations, what is the equation? So in order to graph this, in order to find the equation, the first thing I needed to do was find a table of values that matches the graph. In this thing, x is 1, y is 0, x is 2, y is 3, x is 3, y is 6, and we can stop there. That's fine. That's as far as we need to go. We can do one more if you want, but we don't need to. So once we have that, we're going to find the difference in y divided by the difference in x. And what that's going to tell us is the coefficient of our equation. So when I put x and y down here, since it goes up by 3 here, and it goes up by 1 here, 3 divided by 1 equals 3, which means the coefficient in my equation that shows the relationship between x and y is going to be a 3. Okay? We call that the slope of our line. Once we have that, we can take any ordered pair. I'm going to take the first ordered pair of 1 and 0, and I'm going to substitute that in, 1 for x and 0 for y. And I'm going to ask myself, are those two sides equal? And they're not. And the constant that's required to keep them equal is a -3. So therefore, the equation that matches that ordered pair of 1, 0 is 3 multiplied by the x value minus 3 equals y. And that will also be the equation for any other ordered pair, including all of the ones on the line that aren't even written, because we call that interpolation for the ones between the 2 points we know. And if we go beyond there or beyond here, extrapolation for the ones we don't know beyond the points. Question 6 from chapter 7 says, multiplying and dividing polynomials, what is an expression? So here, for area, we know that area of a rectangle is equal to length times width, or width times length. And when you have a length and a width that are a binomial and a monomial, it's probably best that you treat the monomial as your length. So this could be our length, and this could be our width, multiplied by the width. And now that we've written our expression like that, we're going to expand the multiplication of this monomial by the binomial by using distributive property. And if we think about 3x multiplied by negative 2x, right, when we multiply those two monomials together, it's 3 times x, which is 3x, multiplied by negative 2 times x. The order in which you multiply those 4 terms doesn't matter. So I'm going to do 3 times negative 2 first to get negative 6. And x times x is going to be x squared. So 3x times negative 2x is 6x squared. And then the next part of my distributive property is 3x multiplied by positive 8, or 3 times x times 8, which will be a positive 24x. Now, some people try to gather like terms after this, but you can't, because this term of negative 6x squared and this term of positive 24x are not like terms. So therefore, you can't gather them, and the area of this is negative 6x squared plus 24x. So again, if you made a mistake, please make a note of it, because tomorrow's question will be similar. From chapter 7 on solving linear equations, we have a fairly standard grade 9 question here, where we have fractions on both sides and we have variables on both sides. And what you learned to do was, if you have equations that have fractions on both sides, the easiest thing to do was to multiply both sides by a common multiple of the denominators. And the first multiple that 3 and 6 share is, of course, 6. We can multiply both sides by 6. And if we think about this algebra thing here, if I multiply that side by 6 and that side by 6, I will maintain equality. But when I multiply a side by 6, I'm going to put brackets around it and multiply it by 6. And I'm going to put over here, just multiply by 6. And in fact, why don't we do that for both sides? Why don't we just say, I'm going to multiply this side by 6, and I'm going to multiply this side by 6. And of course, 6 as a whole number, when you're dealing with fractions, is best to be thought of as being 6 over 1. So when I set this up as being multiplying both sides by 6, if I were to multiply the numerators, I would have 6 multiplied by x plus 1 as my multiply the numerators. And when I multiply my denominators, I would have 1 times 3. Over here, you'd have 3x minus 4 multiplied by 6 over 6 times 1. And when I simplify these here, I would end up with 6x plus 6 over 3 equals 18x minus 24 over 6. Okay, and you might be saying, well, hold on. That didn't make it easier. That's still fractions. But now what we have, and I'll extend the page just a little bit here. Now what we have is the ability to use our division of a binomial by a monomial and say, well, what is 6x divided by 3? It's 2x. And what is 6 divided by 3? It's 2. So 6x plus 6 divided by 3 is 2x plus 2 equals, again, we're going to use this idea of distributive property of division. 18x divided by 6 is 3x. And negative 24 divided by 6 is negative 4. So what I've created is I have this equation now where there are no fractions because I multiplied both sides by 6. And once we have that, we now acknowledge we have variables on both sides. What we learned to do was to subtract 2x from both sides to get rid of the variable on one side, leaving with 2 equals x minus 4, right? Because 3x and a negative 2x make an x. I just have a constant left, so I add 4 to both sides and end up with x is equal to 6. That's my solution. Now, alternatively, let's go back up here a little bit here. Let's go, where's my, alternatively, watch this. So when I got to this step here, and I'm going to go back right to the beginning. When I got to multiplying this side by 6 and multiplying this side by 6, what we learned to do is cross-reduce in multiplication, right? Back in grade 8, you learned to cross-multiply or cross-reduce. So 6 over 3 can reduce down to 2 over 1, and 6 over 6 would reduce down to 1 over 1. And the reason why this is important is when I multiply my numerators now, I get 2 multiplied by x plus 1 over 1 times 1. And that over 1 times 1 is not necessary because that's going to give me a denominator of 1, so it's gone, right? And then over here, I get 3x minus 4 times 1, which is just going to be 3x minus 4, because multiplied by 1 is gone, and 1 times 1 is 1. So I end up, by cross-reducing, I avoid a lot of work. And I end up getting down to this by expanding this. And then I end up just doing the same thing I did in the first part. I just subtract 2x from both sides, leaving with 2 equals x minus 4. And then x will equal, because I add 4 to both sides, x will equal 6. I know that's complicated, and we haven't had this talk for a while, but if you kind of follow that train of thought, that's great. If not, just use it as a reference for tomorrow's question, and hopefully we can, by the end of the year, enough practice will make perfect. And your last question, which might not be in any of the other ones because it's not a foundational outcome, comes from Chapter 9 on linear inequalities. Solve for all values of x. So if I go here, I have the difference between linear inequalities and equalities is that x will have infinite values in these particular questions. So if I was to isolate like I would normally do, the first thing I would do is subtract 3 from both sides. Give me x divided by negative 2 is less than or equal to negative 10, right? And I will multiply both sides by negative 2. And I'll put x. Now remember, when we studied linear inequalities, when you multiply or divide by negative values, you have to flip your inequality sign. So because I multiplied both sides by negative 2, I flip my inequality sign, and I end up with the solution of all values that are greater than or equal to 20. So I'm going to put 20 here, I'm going to put 21 here, I'm going to put 19 here. And since it's a greater than or equal to, remember we used a closed boundary point, and any value greater than or equal to will be any value that goes this way on the number line. All values that are greater than or equal to 20. And that's your solution. Okay, hopefully that helps you guys out. Tomorrow, tune back in for your second Reachback of the week. It'll be another 8 questions, maybe 7. I'm not sure yet. And then we'll follow the same pattern for Friday. You'll have your answers video on Friday. Good luck and stay safe and be good to your boomer parents. Get it?